Okay, welcome to our video again. We're going to be looking at solving trig equations based on some of the identities that we've been using, the Pythagorean identities and double angle identities, etc. Let's take a look at this equation here where sine of 2x, here's a double angle, equals sine of x. Look at our, for all angles where x, our angle, is greater than or equal to 0 and less than or equal to 2 pi. So we can be 2 pi and 0. All right, first thing we do is when you recognize an identity like sine of 2x, we'll write the formula down, 2 sine of x cosine of x, 2 sine x cosine x, and that equals sine of x. The next step, notice how I'll subtract sine of x from both sides and get everything on one side of the equation. So the sine x is now here is negative sine x, but 0 is over here. So we moved it over here by subtracting from both sides. So now I've got 2 sine x cosine x minus sine x equals 0. And the next thing you should be thinking about is factoring. I've got a sine x and a sine x, so we factor out, divide out. This term here, let's take out a sine x out of both of these terms. So if I take out a sine x from here, what's left? 2 cosine x. And if I take out a negative sine x, I take out a sine x from here, it's minus 1. We'll check our work. Sine x times 2 cosine x gets me this, 2 sine x cosine x, and sine x times negative 1 is minus sine x. So this is factored perfectly. So it's either, and it all equals 0. So here's our two factors. This in parentheses, 2 cosine x minus 1 equals 0, or sine x equals 0. One of these has to be 0 for this equation to be 0. Okay? So sine x equals 0, or 2 cosine x minus 1 equals 0. Okay, so on this side, I'm going to add 1 to get rid of this and then divide by 2, and I'll get cosine of x equals 1/2. And over here, I don't have to do anything, sine of x equals 0. So remember, what are we doing here? What are the angles that give me this? Okay, you can do in your and some of these you'll have to use your calculator, but for most of these, if it's unit circle questions, you should know them. So inverse sine of 0 gets me the angle, inverse cosine of 1/2 gets me the angle, but you should know off the top of your head. What are the angles that give you 1/2? 60-degree reference angles that are in quadrant 1 or 4 where cosine is positive, pi thirds or 60 degrees, or 5 pi thirds, which is 300 degrees. Sine is 0 at 0, pi, and 2 pi. So 0 and 2 pi because of this right here, less than or equal to 2 pi. Okay, so these are all on the x-axis where your y or sine is 0. Okay, all right, so what do? We had an equation, we substituted the double angle identity for sine of 2x. We collected all trig functions on one side, okay? Factored out a common trig function, set each factor equal to 0, and determine the angles that make each equation true, okay? All right, let's see what else we have. Let's try another one. Okay? This one's in degrees, and you'll have to use your calculator for this. Here I've got 3 sine squared x equals 5 minus 5 cosine x. Okay? So I've got something squared here. You're going to have a quadratic equation. You're going to have to factor in a quadratic equation. Okay? And it's from 0. My angle can be from 0 to 180, including 0 and 180, okay? All right, so here's not 3. So this is x is less than or equal to 180 degrees, greater than or equal to 0, all right? So notice I've got sine squared, but this is in a 5 minus cosine, and this isn't squared. I don't have any identities with just 5 minus 5 cosine x. So anyway, we know what we can substitute in a Pythagorean identity or trig identity for sine squared x, right? So I've got 3, 1 minus cosine squared x. We substituted in for sine squared x, okay? So now I've got everything's in terms of cosine. All right, so notice what we do now. I'm going to distribute this 3 and minus 3 cosine squared x, and we distribute that. So here it is, 3 minus 3 cosine squared x equals 5 minus 5 cosine x. We'll want to get everything on one side. So I'm going to go ahead and I want to keep things positive. So I'm going to move all of this over here, I'm sorry, to keep my leading term. I'd like my leading term, the cosine squared term, to be positive. So I'm going to add 3 cosine squared x over here. I'm going to subtract 3 from both sides. So, okay, and so there'll be 0 left over here. And we're just going to move the 0 to the right side here is what they did here, okay? So by adding 3 cosine squared x to both sides, I've got positive 3 cosine squared x. I moved it over here. I subtract 3 from both sides, so 5 minus 3 is this positive 2. And this didn't move at all. It stayed on the right-hand side. So I've got everything on this side and equals 0, and now we just kind of switch it. So here's 3 cosine squared x minus 5 cosine x plus 2, and we put the 0 to the right now, okay? It's fun, all right? So factor this. This is basically like 3x squared minus 5x plus 2, but we're using cosine x, okay? All right, not too easy, not too hard to factor, okay? What's the only way you can get 2 is 2 times 1, and this is positive, but my middle term is negative, so I know I'm using negative and negative. This is only, we can only get 3 by 3 and 1, so you might have to play with it. You can have the 1 here and the 3 here, the 1 here and the 2 here. You have to move things around until you get what you need, but there's not too many choices, okay? So notice I'll check my FOIL. 3 cosine x times cosine x is 3 cosine squared x. My outer is 3 cosine x times negative 1, which is negative 3 cosine x. Here's a negative 2 cosine x. That will give me the negative 5 cosine x. Negative 2 times negative 1 is plus 2. So either this equals 0 or this equals 0. And let's set them both equal to 0. Okay? I'm going to add 2 over here and then divide by 3, and I get cosine x equals 2/3. That's not a unit circle. We'll have to use our calculator. Okay? Cosine x equals negative 1. I add 1 to both sides. Cosine x equals 1. What are the angles at x where cosine is 1? Just one spot, that's 0 degrees. There's only one spot, okay? Where is cosine? What angle of x gives me a cosine of what angle gives me 2/3? Well, I'll do an inverse cosine. Okay, inverse cosine will get me this, and I get 48.2 degrees. We'll be in degree mode in the calculator. Okay, so you can use your calculator for this problem because you have to. All right, what do we do? We substitute a Pythagorean identity right here. The 1 minus cosine squared x is your sine squared, is for, you substitute in for sine squared x, okay? Collect all trig functions on one side. We factored that equation. We set everything equal to 0. Determine the angles that made each equation true, all right? Let's try one more. Okay, this is in radians again. So here's an equation. Sine of 2x equals root 3 cosine x. You can see the root 3. You ought to be figuring out what unit circle value you're going to see with that. Okay, possibly. And our angle here is from greater than 0, greater than or equal to 0, less than or equal to 2 pi are our possible angles. Okay, and notice on that last one with the 0 to 180, you only had the one angle, cosine 48 degrees. You didn't have a quadrant 4 angle, okay? All right, so remember on that last problem, we had 48.2 degrees or whatever that was. You notice because we are, the domain for the angle x was 0 to 180, we only had, we didn't have the two possible angles, we only had one because we had a quadrant 1 angle, and there's a quadrant 4 angle that'll get us that positive cosine, but it wasn't in the domain for x, okay? All right, anyway, back to this. This is just like the first problem, sine 2x, we'll substitute our double angle formula, 2 sine x cosine x equals root 3 cosine x, okay? We're going to get everything on one side. We'll subtract root 3 cosine x from both sides. So I move this to over here, and I've got 0 now on the right side, okay? Subtracted this from both sides. All right, now let's factor out something. I've got a cosine in both of these, a common factor. So we factor out a cosine x, and what's left is 2 sine x minus root 3. So either, again, cosine x equals 0 or 2 sine x minus root 3 equals 0. Okay? cosine x equals 0, or 2 sine x minus root 3 equals 0, and we solve. Obviously, I'm going to add root 3, divide by 2. Amazing. Look at that. Sine of x equals root 3 over 2. And what cosine x equals 0? It's already done. There's nothing. It's already simplified. Okay. So where is x 0? Well, x is 0 on the y-axis. So pi halves and 3 pi halves. And where is sine of x root 3 over 2? In quadrant 1 and 2, 60 degrees and 120, or pi thirds and 2 pi thirds. Okay? Again, equation. We substitute a double angle identity, the sine 2x, collect all trig functions on one side, set it equal to 0. We factor the left side, or we factor, if we can. Set each factor equal to 0 and determine the angles that make each equation true. Okay? All right, that's all I've got. I'll try to whip up a quiz for you guys, and I'll see you tomorrow. All right? I hope everyone has watched this.